In this episode, we're going to look at congruence and similarity. So, two shapes that are congruent if they are the same shape and the same size. Now they can be rotations or reflections of each other, but they can't be a different size or different shape fundamentally. So there are 4 ways to prove that triangles are congruent. So the first one is the side, 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 or SSS rule. So the 3 sides, if they're the same length, then across 2 triangles or more, then those triangles must be congruent. Another way to work out if 2 triangles are congruent is if the side and the 2 sides and then the angle between those 2 sides are the same, then the 2 triangles must be congruent. That's another way of saying that is side angle side, SAS. Another way you can know if 2 triangles are congruent is if the 2 angles and the side between them, if they're the same, then we know that those 2 triangles are congruent. So again, this is angle side angle, or ASA. And another way to do it is if there is a right angle in both triangles and the hypotenuse and one other side is the same, then the triangles are congruent. So we've got a few. One way to remember that is right angle, hypotenuse, side, RHS. So we've got a few. We've got SSS, side, side, side. We got side angle side, SAS. We've got angle side angle, ASA, and we've got RHS, right angle, hypotenuse, side. So if you can match those up between 2 triangles, then we know that they are congruent. So if we've got a triangle that has 2 sides that are the same, also 2 triangles that have 2 sides the same and the same angle in the middle, the rule we use to know that they're congruent, that would be the side angle side, because we've got 2 sides and 1 angle. Now 2 shapes are similar if they have the same shape but not the same size. So for triangles, one of the following conditions must hold if they're going to be similar. So firstly, all the sides have to be proportional. And what that means is that you can multiply all of the sides by the same number to give the side lengths of the other triangle. Another way is that if 2 sides, if they're proportional and the angle between them is the same, that will allow you to know that their triangles are similar. Or if all of the angles match up in pairs between the 2 triangles, then you know that those 2 triangles are similar. And you can use that to basically work out some missing sides of side lengths of triangle. So if you know that 2 triangles are similar, and you've got one with a side of 16 and 12 and 10, that's your 3 side lengths of your triangles, 16, 12, 10. And you know that the other one has sides of x, unknown, 9, and another unknown. You can basically work out what the relationship is between those 2 triangles to make them similar. So we know that if we take 16 and x divided by 16, so that's the larger triangle divided by the same length of the smaller triangle, and we take 12 divided by 9, 9 divided by 12, then we can say that those 2 are equal. We know that because they've both been multiplied by the same amount, because they have to be, because they are similar triangles. So we know then that x can be equal to 9 divided by 12 times by 16, which would give us x is 12. So we know that if the side is 16 and the triangle is similar, so unknown side we can work out is 12. So if we've got a triangle with an angle, another angle, and a side in between it, and that's the same between a triangle and another triangle, we can use the ASA, or angle side angle rule, to tell that it's congruent. And likewise, if we've got three sides at the same length, we can use the SSS, or side 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 rule, to tell you that it is those triangles are congruent. Now, question. What do we call two triangles that are the same shape but not the same size? They are not congruent, that's when they're the same size and shape, but they are similar. So that is that for congruence and similarity. Join us again next time for more stuff to do with your revision for maths.